The impossible map. Imagine you are standing in the middle of a gigantic, concrete maze. The walls are 20 feet high. You are trapped. You need to find their exit. In our normal world, the world of gravity and solid objects, you have to make a choice. You come to a fork in the road. You can go left or you can go right. If you go left and hit a dead end, you have to turn around, walk all the way back, and then try going right. It takes time. It takes energy. You are limited to being in one corridor at a time. But now, imagine if you could break the rules of reality. Imagine that when you reached that fork in the road, you didn't have to choose. Imagine you went left and right at the exact same time. And not just two paths. Imagine you flooded the entire maze like water. You explored every single dead end, every corridor, and found the exits simultaneously. This sounds like magic. It sounds like a cheat code in a video game. But in the microscopic world, the world that builds the very cells of your body, this is not magic. This is standard operating procedure. This is called quantum superposition. And it begs the terrifying question, if the atoms inside you can be in two places at once, why can't you? Why can't you be sitting here watching this video and relaxing on a beach in Hawaii at the exact same moment? Is the ancient idea of bilocation, or cloning, actually scientifically possible? Today, we are going to dive deep into the most confusing, controversial, and mind-bending concept in physics. We are going to look at the evidence that suggests you might be living infinite lives right now. Welcome to the superposition. Chapter 1, the spinning coin paradox. To understand superposition, we have to stop thinking like humans and start thinking like gamblers. I want you to visualize a coin. Hold it in your hand. Look at it. One side is heads. The other side is tails. In our macroscopic world, the big world, a coin is a binary object. It is either state A heads or state B tails. Even if you put it in your pocket, you might not see it, but it is definitely one or the other. It has a defined reality. Now spin the coin on a table. Give it a really good spin. While that coin is spinning, what is it? Is it heads? No. Is it tails? No. It is a blur. It is a mixture of both heads and tails at the same time. If you were to describe the state of that spinning coin mathematically, you wouldn't say, it is heads. You would say, it is 50% heads and 50% tails. In physics, we call this state a superposition. It is a state where all possibilities exist together in a ghostly overlap. Now here is where it gets weird. When does the coin stop being heads and tails? When you slam your hand down on it. The moment you stop the spin, the moment you measure it or observe it, nature is forced to make a choice. The blur vanishes, and it snaps into a single concrete reality. It becomes just heads. Or just tails. This analogy of the spinning coin is the best way to understand subatomic particles like electrons or photons. Before we look at an electron, it is not a tiny ball orbiting a nucleus. It is a spinning coin. It is a cloud of probability. It is here and there and everywhere simultaneously. It is only when we look at it that it crashes into a single location. So logically you might ask, okay, but a coin is just a piece of metal. An electron is just a spark of energy. Does this really prove that matter can be in two places at once? To answer that, we have to revisit the experiment that broke reality. Chapter 2, the ghost in the machine double slit. Let's go back to our marble shooter. If you shoot marbles at a wall with two holes, slits, the marbles go through either the left hole or the right hole. They hit the back wall and make two neat piles. Simple. Boring. Predictable. Now we shrink down. We shoot electrons. And remember, we are not watching them yet. We are just firing them. When the electrons hit the back wall, they don't make two piles. They create an interference pattern. A pattern of many stripes. Now, wait a minute. An interference pattern is what happens when two waves collide. Imagine throwing two rocks into a pond. The ripples spread out, They crash into each other and they create a complex pattern of peaks and valleys. That is exactly what the electrons did. But here is the impossible part. We fired the electrons one at a time. Read that again. One at time. If I fire one electron and it leaves as a single particle, what did it collide with to create a wave pattern? There was no other electron. It was alone. The only logical explanation, and the one that Nobel Prize winners accept, is that the electron did something impossible. It approached the two slits. It went into a superposition. It went through the left slit. It went through the right slit. It went through neither. And it went through both. It effectively cloned itself, turned into a wave of potential, went through both doors, collided with itself on the other side, and then hit the wall. The electron interfered with its own ghost. This is bilocation. This is scientific proof that matter, the stuff you are made of, can exist in multiple locations simultaneously as long as nobody is watching. Deep dive. Can we change the past? The delayed choice. If you thought the double slit experiment was weird, wait until you hear about the delayed choice quantum eraser. This is the experiment that made Einstein question reality itself. We know that if we measure the electron, it behaves like a particle. If we don't, it behaves like a wave. But scientists asked a crazy question. What if we trick the electron? What if we let the electron go through the slits first, as a wave? And then, after it has already passed through but before it hits the wall, we decide to measure it. Basically, can we force the electron to go back in time and change its decision? It sounds like science fiction. But when they ran the experiment, the impossible happened. Even though the electron had already passed through the slits as a wave. The moment they decided to measure it at the very end of its journey, the electron retroactively changed its history. It acted as if it had been a particle the whole time. This implies something terrifying. Time does not exist for quantum particles. Your decision to observe something now can literally rewrite the history of how that thing got there. The future caused the past. Just think about that for a second. In our macro world, cause always comes before effect. You kick the ball, then it flies. But in the quantum world, the ball hits the goal, and because it hit the goal, you decided to kick it 5 seconds ago. This suggests that the universe isn't a linear story being written page by page. It is a completed book, where the beginning, middle, and end are all interacting with each other constantly. Chapter 3. The problem OFDCOHERENC. But this brings us to the big, frustrating problem. The problem that makes you bang your head against the wall. You are made of electrons. Trillions of them. So if every single brick in your body can be in 2 places at once, why can't you? Why can't you walk through 2 doors at once? Why does the magic stop when things get big? The answer lies in a concept called quantum decoherence. Think of a quantum superposition, that spinning coin, as a very, very delicate bubble. Inside that bubble, the particle can dance. It can be in multiple places, it can be magic. But this bubble is incredibly fragile. It hates interaction. If a single air molecule hits it, pop. If a photon of light hits it, pop. The moment the bubble pops, the superposition is destroyed. The quantumness leaks out, and the particle is forced to choose a single location. This popping is called decoherence. Now look at yourself. You are not a single isolated electron. You are a massive, hot, wet, noisy collection of 7 octillion atoms. You are constantly interacting with the environment. Air molecules are bouncing off your skin. Light is hitting your eyes. Your body heat is radiating infrared energy. Gravity is pulling on you. You are constantly being touched by the universe. Because of this constant interaction, your quantum bubbles are being popped trillions of times per second. You are decohering faster than you can blink. You are leaking quantum information into the environment so fast that you appear solid. It's like a spinning fan. If the fan spins fast enough, superposition, It looks like a transparent blur. You can look through it. But if you throw rocks at it, environment interactions, you will hear the clack 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 and you will see the solid blades. The environment is throwing rocks at you constantly. So, does that mean the dream of cloning or parallel realities is dead? Absolutely not. Because there is a theory that suggests when the bubble pops, the other possibilities don't disappear. They just go somewhere else. Chapter 4, the most famous cat in history. If you mention quantum physics, someone will inevitably mention Schrödinger's cat. It is the pop culture mascot of physics. But 90% of people misunderstand what this cat actually represents. They think it's a cool example of how magic the universe is. But Erwin Schrödinger didn't create this experiment to show how cool quantum mechanics was. He created it to show how stupid it was. Here is the setup. You take a steel box. Inside, you put a live cat and a tiny bit of radioactive substance. In 1 hour, there is a 50% chance an atom will decay, triggering a hammer that smashes a vial of poison, killing the cat. You seal the box. You wait 1 hour. According to quantum mechanics, the radioactive atom is in a superposition. It has decayed and not decayed. Because the cat's fate is tied to the atom, the cat inherits this state. Until you open the box to check, the cat is mathematically alive and dead simultaneously. Schrödinger's point was, look how ridiculous this is. A cat cannot be alive and dead, it's either breathing or it's rotting. But the cosmic joke is, Schrödinger was wrong. The universe is that ridiculous. But this leads to the darker question. The question that keeps physicists awake at night. When you open the box, what happens to the version of the cat that didn't survive? Or if you see the cat dead, what happened to the version that was alive? Does nature just hit the delete button on a reality? Chapter 5, The Man Who Split the Universe Many Worlds. Enter Hugh Everett III. In 1957, this Princeton student asked, what if the wave function never collapses? What if, when you open the box and see a live cat, the dead cat reality doesn't disappear? Instead, what if the universe splits? This is the many worlds interpretation, MWI. Imagine the timeline of the universe is a rope. At the moment you open the box, the rope unravels into 2 separate strands. In strand A, your universe, you see a live cat. In strand B, the other universe, a version of you sees a dead cat. Both events happened. Both are equally real. But they are now separated by an impassable barrier. This brings us back to your question, is cloning real? Under the many worlds theory, you are the most prolific cloner in existence. Every time a quantum event happens in your body, the universe splits. Every time you make a choice, left or right, coffee or tea, fight or flight, reality branches. There is a universe where you bought Bitcoin in 2010. There is a universe where you married your high school crush. There is a universe where you became a rock star. You are not just one person. You are an infinite choir of voices, singing every possible song of your life across a limitless multiverse. This is the ultimate quantum superposition. Deep dive, quantum suicide and immortality. If the many worlds interpretation is true, we arrive at the most disturbing concept in all of physics, quantum immortality. Let's go back to Schrödinger's cat. But this time replace the cat with you. You are in the box. The gun is pointed at your head, triggered by the radioactive atom, 50/50 chance. You pull the trigger. From the perspective of your family outside the box, there is a 50% chance they will find you dead. They will cry. They will bury you. In their timeline, you cease to exist. But what about from your perspective? You are the observer of your own consciousness. You cannot observe yourself being dead. Being dead is the absence of observation. So according to the math, your consciousness must follow the branch where the gun didn't fire. You pull the trigger. Click. Nothing happens. You are alive. You pull it again. Click. Alive. In the multiverse, there are billions of universes where you died. But your consciousness can only ride the timeline where you survive. To everyone else you are mortal. But to yourself, you might be statistically immortal. Now, does this mean you should go play Russian roulette? Absolutely not. Because in 99.99% of universes, you will devastate your family. But it forces us to reconsider the nature of death. Maybe death isn't the end. Maybe it's just a shift to the branch where you woke up this morning. Chapter 6. The God Machine Quantum Computing. Now I know what you are thinking. This sounds like science fiction. But what if I told you we have already built a machine that taps into this power? Remember the maze. A classical computer like your phone solves a maze like a fast mouse. It checks path 1, then path 2, then path 3. It thinks sequentially. But a quantum computer uses qubits. A qubit can be 0 and 1 at the same time. It creates a superposition of every possible path simultaneously. It floods the maze like water. It checks all 1 million paths in a single heartbeat. This is not just faster. This is a different species of intelligence. A problem that would take the world's best supercomputer 10,000 years to solve. A quantum computer can solve in 200 seconds. We are building a machine that harnesses the cloning power of the universe to solve our biggest problems. Chapter 7. The Quantum Compass Biology. But here is the most humbling twist. Nature beat us to it. Biologists used to laugh at physicists, saying quantum effects couldn't exist in warm, messy living bodies. They were wrong. Look at the European robin. It migrates thousands of miles every year. How? It has a quantum compass in its eye. Inside the bird's retina, a protein called cryptochrome creates an entangled pair of electrons. These electrons are in superposition, making them hypersensitive to the Earth's magnetic field. Basically, the bird can literally see the magnetic field as a visual pattern. It navigates using quantum ghosts. Or consider photosynthesis. When a plant absorbs sunlight, it needs to move that energy to a reaction center. Evidence suggests the energy goes into superposition. It takes every possible path to the reaction center simultaneously, finds the shortest one instantly, and takes it. Every leaf in your garden is performing a quantum computation every second of the day. Deep dive. Walking through walls, tunneling. We have talked about cloning and telepathy. Now let's talk about walking through walls. In classical physics, if you roll a ball up a hill and it doesn't have enough energy, it rolls back. But in the quantum world, particles cheat. Because a particle is a wave, sometimes it simply vanishes from one side of the barrier and reappears on the other side, without ever climbing over it. This is called quantum tunneling. You might think, who cares? You should care. Because without this, the sun wouldn't shine. The sun smashes hydrogen atoms together. But hydrogen atoms repel each other. The sun isn't actually hot enough to overcome this repulsion. So why is it burning? Because the hydrogen atoms use quantum tunneling. They cheat the barrier and fuse together anyway. Every ray of sunlight is a result of a particle walking through a wall. But tunneling has a dark side. Your DNA is held together by protons. Sometimes a proton tunnels. It jumps to the wrong side of the DNA ladder. When your DNA replicates, this causes a reading error. A mutation. The very force that powers the sun is also the force that drives evolution and cancer inside your cells. Conclusion: the observer's paradox. So where does this leave us? The question, can you be in two places at once, has a complicated answer. Physically, in this macro reality, no. The environment is constantly measuring you, pinning you down to one location. But fundamentally, yes. The particles that make you up are borrowing the magic of the multiverse to keep you alive. Quantum superposition tells us that reality is not a fixed, rigid stage. It is a field of infinite possibilities waiting for an observer. In the many worlds theory, every regret you have is a victory in another timeline. Every what if is a reality somewhere else. But you, the consciousness listening to my voice right now, you are the traveler of this specific branch. You are the one who gets to observe this life. And perhaps the lesson of quantum physics isn't just about atoms and lasers. Maybe the lesson is about focus. If observing a particle creates its reality, then what you choose to focus on in your life is literally constructing the timeline you walk down. You are the ultimate observer. The wave function is waiting. Which reality will you collapse next? Thank you for watching, and welcome to the Quantum Files official.